Since the dawn of philosophy, humanity has debated if free will exists, or was an illusion in a predetermined universe, or even if somehow both could be true at once, and compatible concepts to each other. Either way, I hope you'll choose to stick around for the rest of the episode. The relationship between quantum mechanics and the concept of free will is a fascinating and complex topic that intersects physics, philosophy, and neuroscience. Many in the sciences felt the debate was closed going into the start of the 20th century, but then we got quantum mechanics, with its seemingly random and probabilistic nature, and the principle of superposition, the idea that two outcomes, like Schrodinger's living and dead cat in a box, could be simultaneously true until observed. This seemingly introduces a level of indeterminacy and unpredictability at a fundamental level of physical reality. If all the universe is random, how can it possibly be predetermined after all? This has led some thinkers to speculate about its implications for free will, a topic that has been debated for centuries in philosophy and more recently in the context of the cognitive sciences. As we learn more about our universe and how it works, we've also learned more about our minds and how they work, and it shakes our worldview in this most fundamental way, challenging if we can truly even make up our own minds. Carl Jung once said, "Free will is the ability to gladly do that which I must do," and coming from one of the founding fathers of psychology, I always take that quote to be about how our choices exist, but that our personal psychology so strongly influences and predetermines our picks that only in rare cases are we truly making a decision. Cases of incredibly even choices or deeply conflicted priorities. Science also tells us that making decisions is one of the most stressful and draining things we can do, even minor decisions. So I thought we would examine what else science has to say about decisions and free will in today's remastered and expanded edition of Our Look at Free Will, Quantum Mechanics, and Orchestrated Objective Reduction, or ORC-OR. And since this episode was originally released on Nebula last year and expanded for today, as a heads up, much of that expansion comes after the sponsor read, not just our usual upcoming schedule or channel announcements. Since I can never tinker with an episode without adding to it, as such, we will be here for a bit, and a drink and a snack might be a good idea. And please hit those like and subscribe buttons for alerts when new episodes come out. So, what is free will? On the one hand, that seems obvious. We get to choose our next action. Phrased a bit more formally, free will is the idea that humans have the capacity to make choices that are not predetermined by past events. Philosophical discussions on free will often revolve around the debate between determinism, which is the belief that all events, including ethical choices, are determined by previously existing causes, and libertarianism, not to be confused with the political ideology, which is the belief in free will, that decisions are not predetermined but result from conscious choice. The very nature of the field of psychology relies on the notion that human behavior is predictable, that our minds and behavior follow certain rules, and this obviously can seem in conflict with the idea that you are your own master and free to make decisions and control your fate. And yet there's also that one step further, which was popular in the 19th century and the early 20th, that everything was predetermined and that you could, at least in theory, calculate every future event by building a computer big enough to determine where each particle would be next, and push that out all the way to eternity if need be, or backwards into the past to uncover ancient history and events, or even resurrect the ancient dead by being able to precisely determine the position of every atom in their brain. Now, this was not actually possible since the computers involved would need to exceed the universe's own mass, and account for their own behavior such as power generation and heat exhaust. But whether we could actually calculate each particle's movement didn't change that it was calculable, and thus predetermined, and that even the atoms in your brain would be working mechanistically to predetermine decisions. Every thought you have should be the product of inevitable physical and chemical interactions. Now, the arguments if we have free will and what free will actually is have been going on at least since Aristotle's time, and in truth, the discovery of Newtonian mechanics didn't really change that conversation by adding much genuinely new material beyond empirical proof that stuff happens for a reason, and if you know the motion and other variables of a system well enough, you can predict its outcome. Again, quantum mechanics rather messed with that idea, and more recently, Roger Penrose's theory of orchestrated objective reduction, again Orc-OR, or sometimes Orc-OR. Now, in some way, quantum shouldn't really have changed that argument. We do not know why quantum effects are genuinely random, but they show every evidence available of being so. Which is not to say they truly are, we don't know. Nonetheless, I wouldn't think a random factor itself grants free will. If your brain is a machine and operates in accordance with certain rules, the fact that some given input might be genuinely random, as quantum implies, as opposed to non-random but impossibly huge to calculate, as Newtonian mechanics imply, would not seem to change anything. No computer is possible that can predict the future far ahead in an entirely Newtonian universe, and few quantum events percolate to the macroscopic scale enough for it to alter decisions. Penrose offers a possible third route, which we'll get to in a bit, but introduces the notion of a space-time blister, and that our minds might operate inside them. Either way, whether or not you have free will should not be affected by whether or not someone else can actually predict your actions, and so too, my ability to read a history book and know what Caesar or Charlemagne or Genghis Khan did wouldn't seem to pertain to whether or not they had a free will choice at the time. By that same reasoning, some time traveler or someone existing outside our space-time, such as God is suggested to be, wouldn't seem to violate that free will either, but they know my actions. Nor does it seem pertinent that we can guess how people will react in most cases, where their decision is reflecting an instinctive reaction like flinching, or a simple logical conclusion like that their gas tank is low and the next highway exit has one gas station and no others for 20 more miles. Knowing someone is going to pull off and fuel up there doesn't really indicate that somehow they have no free will in the matter. They will stop for refuel because it's the wise action. Doing so would not seem to pertain to if they had a choice. We also do not know that quantum effects are random, and indeed in the mini-worlds theory, that's the more popular multiverse type, every possible event of any sequence of events occurred in parallel universes, and all our decision indicates is which one of those we were in, as opposed to a version of us who decided the opposite. I'm not sure how free will exists in this context, since you and your clones made every choice possible, including stupid ones. Folks more familiar with the philosophical contemplation of free will and determinism probably won't be too surprised to find out I tilt toward compatibilism, which we'll return to in a bit, but in quick summary is the notion that you and I have free will and that the concept is compatible with a deterministic universe. The emphasis is on tilt. I have no official stance on it, much like the Fermi paradox. The general notion there is that there's a false dichotomy in assuming free will requires alternative possibilities to pick from, and thus clearly cannot exist with determinism. By this same logic flipped around, free will cannot exist in a mini-world setup because every option is already predetermined to occur. Though one might argue the same is true in a universe of infinite size or duration, and I'm not sure someone else identical to me, 50 quadrillion light years away, deciding his actions much like mine, has any pertinence to if I or he have free will either. So even in Penrose's model, whether or not we have free will would still depend on which quantum model turned out right. Mini-worlds Copenhagen, that's the Schrodinger's cat scenario of overlapping realities till looked at. It could also be one of the other options besides mini-worlds and Copenhagen interpretation, of which there are tons of lesser known ones, and tons of minor variants too. But to get to orchestrated objective reduction, I need to clarify that this isn't just the idea that our brains, while mostly above the quantum scale, still have quantum effects on our neurons and thus thinking. Thus, even if a computer controlled all your inputs precisely, it could not say for sure what you would do, and increasingly less so as time goes by and that quantum noise starts stacking up uncertainties or deviations. Essentially, a given neuron or thought can be seen as an analogy for Schrödinger's cat, especially in very borderline cases of decisions. If, to oversimplify, a decision was being made by a vote or action of 100 neurons, and each has a roughly 50-50 chance of picking A or B in that decision to get a drink or a snack, for instance, we aren't actually 50 votes yes and 50 no. It's the most likely single outcome, but not likely overall, it being some other option like 49 and 51 or 47 to 53 is considerably more likely, and we get some sort of bell curve distribution. No one would argue that very occasionally, at least, a quantum effect is going to permeate up to the neuron scale, and in a way that would flip that switch to a different outcome than it otherwise would be expected to be, resulting in a different decision, which again does not necessarily mean that result was truly unpredictable, or that even if it were, that the universe isn't deterministic. The existence of background random noise does not imply you're a free agent able to make decisions, just that no one could calculate what they would be. You are still an automaton, which isn't really free will any more than assuming a book character had free will because the author hasn't written the page yet, and you and I haven't read it, or it got written and burnt before anyone else could see it. Randomness or uncertainty doesn't simply grant agency by their existence. So what is OR? Well, you might have heard of Gödel's incompleteness theorem, which essentially posits that very nearly any logical system has either got contradictions in it, or statements you can't prove by using it. We'll skip the math of that, but to use a quick example from a card game like poker, there are specific types of allowed hands and cards. You can have 5 cards, not 4 or 6 or 10,000, and in the 52 card deck, there's only one Queen of Hearts, so you cannot have a hand with 2 Queen of Hearts in it. Every hand in the game has a value and beats or loses to another hand. No ties are allowed. Presumably, every single permutation of the cards has to be comparable to every other hand you can get, and a winner declared. Again, there are no ties in this game. Even if we countered a case where we had 2 hands of equal value, for which no winner could be determined, you could say, fine, we just make up a new rule to decide who wins this sort of tie. So if 2 players both dropped a pair of jacks and a pair of 5s, we could have a rule saying the person with the highest 5th card won, but then what do we do if those are the same? We could have a rule added requiring that each be dealt another card till one of them won, or that hearts trumped diamonds, or that whoever dealt that first card of that game won, or the oldest player won, and so on. Gödel is arguing that you cannot ever cover 100% of the cases. There is always going to be some way of having a tie you have not covered yet. That's a bit of an oversimplification, and so would be extrapolations like it being impossible to prevent all crime, or make a system of rules that was 100% fair and just, or that no matter how complex your internal system for making decisions is, there will always be something the rulebook does not cover yet. And again, that's very oversimplified to the point of being arguably wrong, but it helps visualize it better. Though there's more to the idea than simply that no system can be entirely complete and self-functioning, or self-consistent for that matter. Science cannot be used to prove science is right. The assertion that the scientific method is the best way to find the truth is an inherently unscientific statement. Gödel is also principally a math concept that arithmetic cannot be used to prove arithmetic works, and thus shouldn't really be extrapolated to cover deep philosophical concepts, but it does get extrapolated that way a lot, and many scientists, including myself, are guilty of doing that. In this case, Penrose introduces both humans and quantum into Gödel, that Gödel's unprovable results are provable by humans, and thus we must be running a non-computable algorithm. To quote Penrose, the inescapable conclusion seems to be mathematicians are not using a knowably sound calculation procedure in order to ascertain mathematical truth. We deduce that mathematical understanding, the means whereby mathematicians arrive at their conclusions with respect to mathematical truth cannot be reduced to blind calculation. Or again, to simplify, math and science cannot be used to prove their own validity. Additionally, Penrose determined that the wave function collapse, that's what happens when you open the box and Schrödinger's cat is forced to be either alive or dead, not both at once, is a prime candidate for being a non-computable process. Tricky issue in quantum is that you cannot, for instance, prove if quantum determining events like a wave function collapse occur in the absence of a human observer. Outside Schrödinger's cat box is a room with a scientist named Wigner inside and a sealed door, who may or may not have observed a dead or alive cat, but someone outside that door does not know which till he opens that door either. We don't know what event or observation officially locks the event in place. Maybe none. Maybe only a conscious and intelligent observer. Maybe any random interaction of particles. Maybe only God and what he sees matters. Or maybe there's many worlds after all, and there are separate universes for each possible permutation of an event. But you, a conscious mind, can only know the outcome after a conscious mind, you, has observed it since you are one, and thus cannot know if you were necessary or not to make that waveform collapse. Indeed, it might only be your mind specifically that matters. You might be a Boltzmann brain, for instance. You can never prove a conscious mind was not necessary, though that does not prove a conscious mind was necessary either. Penrose is also arguing that isolated systems would still undergo wave function collapse, which is to say that box with a cat in it eventually resolves regardless of if you open it up. This is the orchestrated reduction under discussion. This is pretty deep quantum and math too, which we will have to skip, and that in the meantime we have a space-time blister, one that gravity exerts force on, and the time this takes to reach orchestrated reduction is based on the mass involved, with something like an atomic scale trigger having millions of years before orchestrated reduction, while something in the cat mass region has a period of time far less than even a nanosecond, and closer to a Planck time, what we usually regard as the smallest possible moment. Everything at the brain scale resides between these two scales, our brain being built of atoms and less than a cat mass worth of them, and thus likely occurs at a timescale meaningful to brain function and human consciousness, that this makes our mind able to support non-computational thinking and thus not be deterministic, and that this is also the basis of human consciousness, a quantum consciousness, via microtubules in our neurons that are in a fractal pattern permitting this quantum consciousness. But we will not further delve into that since this is a bonus Nebula episode rather than a full-length one, and I think we would need a very long episode at that to further explore it properly. Indeed, longer than this remastered version I'm writing and recording in mid-spring of 2024. Personally, I love the argument, though the real argument is much more math and physics heavy, much like Gödel, so don't worry if the puzzle pieces seem about right but don't lock together perfectly. That's just me trying to simplify things down and probably mangling them a bit in the process. Also, part of why I did this episode for Nebula rather than YouTube, as I suspect it would frustrate a lot of folks and trigger YouTube's more unkind algorithms. Which, since I decided to put it on YouTube after all, I shall soon find out. Needless to say, the theory attracts criticism from many academics and often attracts folks more on the quantum mystic side than science side, but the big one from the physics side of it is that some feel our brains are too warm, wet, and noisy, to quote Max Tegmark, not to have almost constant near-intermediate waveform collapse. Note that this doesn't matter for the purpose of simple quantum randomness making you unpredictable, just the idea that bits of your brain, or its entirety, can't be sitting in this Schrödinger cat-like state for an actual decision, and that this is where consciousness rather than simple randomness is emerging from. And as a side note, if we are assuming your free will is based on quantum randomness existing until a conscious mind observes it, given that your conscious mind is consciously observing your brain all the time, this gets a bit logically strange to contemplate. Orc-OR is definitely not a proven theory, but I've seen some say it's been disproven, and I think that's a bit of a stretch. But the same goes for folks saying science has or will show free will is a myth or illusion. That tends to get confidently asserted by folks without any follow-up as to why that should be, and I'm not familiar with anyone staking their academic reputation on that claim either. Also, as Penrose's good friend, the late great Stephen Hawking once commented, I have noticed even people who claim everything is predestined and that we can do nothing to change it, look before they cross the road. I'll add on to that 2 quick notes. First, science doesn't say if we have free will or not, but has shown repeatedly that one of the big correlations in life on being successful or not is if you believe you have significant control over your own fate and your decisions matter. Which would be an incredibly ironic and maybe even sadistic circumstance if free will really did not exist. But believing in the lie of it was apparently beneficial. If we put that in a Pascal's wager format, where we have 2 variables, whether free will exists and whether or not we believe it does, we get 4 options. It exists and we think so, it exists and we don't, it doesn't exist and we believe it does, and free will does not exist and we believe it does not. You only get to control if you believe or not, and you're not out of anything if you believe in free will and it doesn't exist, and furthermore you never had a choice to believe it or not, or to break the law or not, steal or kill or not, etc. The only bad choice then is to have free will but not believe you do, so you might as well believe you do. That said, this does not require one to ignore that our universe and indeed our own minds are pretty predictable. I am not stealing your agency or ability to decide by noting that you look a little dehydrated and offering you a drink because I know you're thirsty. But this is where compatibilism comes in as a popular option among philosophers, to wrap up our topic for the day. And as I mentioned earlier, the incompatibilism viewpoint is the one that says free will can only exist if cause and effect do not force our decisions. And since cause and effect so clearly do, there's no free will in our Newtonian universe, or likely even in our quantum universe. For my part, I don't think it really matters if your actions are predictable or not, since I generally view it as a notion of personal responsibility, and I will just flatly say I simply choose not to believe in any philosophy which denies free will, and if I'm wrong, well, it's not my fault, I didn't have any choice. I'm not going to deep dive compatibilism, sometimes called soft determinism, as in contrast to hard determinism with no free will, but it's not a mix of viewpoints or compromised perspective incidentally, nor partial or limited free will. Rather, it's just the general notion that since nothing is stopping me from sipping my coffee right now, I have the free will to pause and drink it, or to finish typing this sentence first. This is not the same as the ghost in the machine style approach that assumes that humans have some inner quality that lets us make decisions independently of cause and effect, or arguably science. Though this is not just limited to supernatural cases like a soul. Personally, I'm fine with that one too, and I do tend to waffle back and forth onto that one. You could argue that is what objective orchestrated reduction is an example of, but fundamentally there's tons of different angles on these things, so you do not need to get boxed in if one of those 3 doesn't appeal or seem reasonable. There's lots of variants and entirely different camps too. The point to wrap up on, before our brief break anyway, is that you are of course welcome to view free will however you like. An illusion of our minds, which might make it a great answer to the Fermi paradox. Civilizations stop believing in free will and stop bothering to struggle or achieve or even exist. Or you can view it as an unknown quantity of unexplored science or supernatural aspects, or the soft determinism route, but don't feel like science requires you to pick one of them. Truth be told, science really has not altered the arguments used by any of those camps beyond giving some more specific examples. They've been around a long time. Fundamentally, whether you believe in free will or not is up to your preference and choice, and either way, thanks for choosing to join us today and stick around for more discussion of quantum and its relation to free will in Part 2. We'll return to our topic in a moment, but as mentioned, the original version of this episode aired on Nebula last year, and we have a new episode that comes out on Nebula every month that stays exclusively there for a year. They also run without any ads or sponsor reads like this in them, so you can watch them from start to finish, and you can do the same for all of our episodes, which is about 8 a month, and includes our audio-only versions for our listeners. But it also includes a lot more content than just our show, with an ever-growing number of creators releasing their content to Nebula, which is now the largest creator-owned streaming company out there. You can join now for about $2.50 a month, about the price of the drink or snack you've been enjoying during the episode. But we also now have lifetime memberships available and gift cards that let you share Nebula with friends and family. And if you join now, you not only get to see all the exclusive and ad-free content already out on Nebula, like this month's ISRU, In Situ Resource Utilization, you also be just in time to catch next month's Planetary Archives and Stasis Faults, coming out midnight, July 1st. When you sign up with my link, go.nebula.tv/IsaacArthur and use my code IsaacArthur, you not only get to see all the great stuff Nebula offers, like In Situ Resource Utilization and Planetary Archives and Stasis Faults, you also be directly supporting this show. And again, for those of you who want to share everything Nebula has to offer with your family and friends, Nebula is now offering annual gift cards. Use the link gift.nebula.tv/IsaacArthur to give a year of Nebula to a friend for just $30. After originally writing this episode, I felt we didn't really discuss the implications of quantum mechanics as much as we should have, as I was trying to place the focus on Penrose's Orc-OR specifically, and in hindsight there, I felt we abridged the discussion of quantum on free will more generally a bit too much. For instance, some interpretations of quantum mechanics suggest that because events at the quantum level are not strictly determined, but rather are governed by probabilities, this indeterminacy could be scaled up to more macroscopic levels, potentially influencing the brain's function and thereby human behavior and free will. This is essentially what Orc-OR relies on too, but is not exclusive to Penrose's theory, which, as we discussed, goes into the idea of space-time blisters as well. This viewpoint generally suggests that if our brains operate, at least partially, on quantum mechanical principles, then the indeterminacy inherent in quantum mechanics could provide a mechanism for free will, as our choices could not be strictly determined but influenced by probabilistic quantum events. I am sorry, by the way, that this sounds so much like technobabble from sci-fi, and at least partially because sci-fi writers prone to technobabble tend to draw on these concepts for reference. The brain is a complex organ operating at mostly the macroscopic level, our day-to-day level of the visible, some argue entirely, where classical mechanics predominates and predestination would rule, and quantum effects might play a minimal or highly specialized role. But the extent to which quantum effects actually influence brain activity and decision-making remains a subject of ongoing research and debate, so we cannot simply say it is surely predetermined and mechanistic. To me, the warm, wet, squishy argument that this is very minimal is irrelevant. If quantum is ever resulting in any action which alters your thinking of some path mechanistically predetermined, then it isn't predetermined. If even just one neuron in your whole life switched differently than it would otherwise have because of quantum, it not only disrupts predetermination, but the butterfly effect will cascade beyond that. So too, what matters if the quantum event that changed things was in your brain or simply in the environment around you that you draw your inputs from? We've got some switch that either turns on a light or not based on one random decay, and you were there to see it, and your whole life is impacted by that. And this is very real. As we noted back in our Infinite Improbabilities episode, we do have online random quantum pickers people can use, and in that episode we used one to pick the lunch menu, which resulted in the selection of a cheeseburger, and is how that episode got the nickname of the Quantum Cheeseburger episode, which has been a standing joke on the show for years now, and all by itself rippled out to impact the show quite a bit, and its audience, and everyone that audience interacted with. That event genuinely altered every moment of human history thereafter. What does it matter if the quantum event was on a computer switch somewhere rather than specifically in my brain? Or would we argue that now humans do have free will by using such machines, but before we did not? Seems thin on reasoning, and thus whether OR is right or not, and whether or not your own brain is warm, wet, and squishy enough that it is not altered by quantum effects very often, seems thin reasoning for dismissing quantum from free will considerations too. Now, that said, this perspective is not without its critics. Many scientists and philosophers argue that quantum indeterminacy does not necessarily translate to free will in the philosophical sense. Like I mentioned earlier, just because quantum seems random does not necessarily mean it truly is. And, even if it were random, that does not mean we have free will automatically. After all, a book character has no free will, and just because that character was in a book typed by an infinite number of monkeys randomly whacking keys to some segment by luck was a coherent novel with a protagonist, does not mean that protagonist has free will either. So we can argue that randomness or unpredictability at the quantum level does not equate to the conscious exercise of free will. Instead, perhaps, it introduces an element of randomness into physical processes that could be fundamentally different from the concept of making free, intentional choices. The relationship between quantum mechanics and free will is a deep and unresolved question that challenges our understanding of both physics and the nature of consciousness itself. While quantum mechanics introduces elements of indeterminacy and probability that contrast with deterministic views of the universe, translating these principles into a framework for understanding free will requires careful consideration of both the scientific and philosophical dimensions of the equation. Needless to say, the debate continues to evolve as our understanding of both quantum mechanics and the workings of the brain deepens. Indeed, since this episode was originally written and now, OR got a decent bump, first from Trinity College in Dublin doing some experiments that suggested our brains might do quantum computation, and then some indications our brain's decision-making indicates quantum behaviors. For instance, in classical physics, the order in which you ask questions should not impact how you answer them, but we find humans do alter their answers based on the order asked. See the article Brain as a Quantum System, Theory Gets New Traction by Dennis O'Leary from 2024 for more discussion of that. The interplay between quantum mechanics and the notion of free will presents a profound and yet to be resolved inquiry that stretches the boundaries of physics and our comprehension of consciousness itself. As research progresses, particularly the intersection of quantum physics and neuroscience, this debate is poised to deepen, challenging our existing paradigms and potentially reshaping our understanding of free will in the context of the quantum world. Nobody knows what that answer is yet, so for now, we're free to choose which we'd like to believe in, assuming we can choose, of course. For those curious, as I tend not to spend much time explaining channel processes during episodes as it gets boring to new viewers, this episode was originally released on Nebula back in summer of 2023, and was one of the first episodes recorded after my surgery to help correct my speech impediment. As you may or may not know, we've been doing extended editions of some episodes for Nebula exclusives in 2021 and 2022, but in 2023 by popular request started shifting to separate bonus episodes, and most of the first handful were originally more of short companion episodes for other episodes. Combined with them being shorter and recorded pre-surgery, I decided to dip into them in greater detail and just re-record them. By the end of that summer though, I had decided that every Nebula exclusive would come out on YouTube a year after release, and mostly after writing today's episode and next month's. It was the first truly standalone Nebula exclusive written that way from the outset, while next month's was still a companion piece, and after that I decided to just treat them like regular episodes, albeit aiming to keep them a bit on the shorter side, which, as you might guess, did not last long, and most produced in 2024 thus far are normal length. Still, as I was getting ready to prep this one for direct release to YouTube, I felt the audio was a bit subpar, the surgery was still fresh, and I hadn't made much progress on my newest round of speech therapy. And that I had a few more points to add too, so since I needed to re-record it anyway, I did expand and adapt on this episode a bit. Given the topic of today, I suppose we could debate if I chose to re-record and expand the episode or was predestined to, but in any event, it seemed a good idea. So that's it for June, but we'll jump into discussing more existential crises on July 4th as we look at Roko's Basilisk, a strange acausal concept that might spell doom for humanity, and backwards in time at that. After that, we'll examine a different pathway for humanity with a look at cyborgs and cyborg civilizations. Then it'll be time for our 2.5-hour feature-length summer special, the Interstellar Colonization Compendium, covering everything from the ships we'll use to get to other stars, to how we'll use them and what we'll do when we get there. Followed by a look at the idea of ancient dormant alien empires on July 14th. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show by becoming a member here on YouTube or Patreon, or check out other ways to help at isaacarthur.net. You can also catch all of SFA's episodes early and ad-free on our streaming service Nebula, along with hours of bonus content like in-situ resource utilization at go.nebula.tv/isaacarthur. As always, thanks for watching and have a great week.